Okay, everybody, back to lesson 76. We're going to go ahead and talk about the second part of today's lesson, which involves negative vectors. All right, so let's just refresh our memories. We know that a vector is something that has both, it's a quantity that has both a magnitude and a direction. And I'll just point this out as we go along. If you want to open your books, it might be easier for you to look at this particular image in your books. Go to page 317 with me. At the bottom, you're going to see there 76 point B, negative vectors. So as you're looking at that, and as you're going there, I'm going to quickly draw it out so we can look at it together. You have your axes here, your X and Y, and you have this vector that's drawn like this. At 30 degrees, you've got a point out here. This is 30. And it shows that this line segment here is 8.66. This is 5. And it shows also this degree measurement coming around a negative. We've talked about negative. You can measure an angle from a negative direction as well. Normally, remember with a polar coordinate, normally we start at the x-axis and we go this way, right, to measure. And that's okay. We could do that too, right? Whoops, it would go up. Oh dear, what was that? Anyway, we could do it in a positive direction, which feels like it's negative, but it's not. Or we could do a negative vector, which starts underneath the x-axis and goes around to where the line of magnitude is. Okay, so here, let's just refresh our memories again. So a vector is a quantity that has both a magnitude and a direction. And we know that the magnitude is this line right here. That's the magnitude, or the line of magnitude, which we always know when we draw this hypotenuse. It's always the hypotenuse when we draw this right triangle down here, right? And then, of course, the direction is talking about the angle. Okay, so whatever your angle's measurement is ends up being what the direction. So it's all in discovering where this point is on your graph. So really, whenever we're solving these things, in case you haven't really put that together, it's where's the location of that point. We can use this vector to discover the line, the point's line there. Or we can also use not just a polar coordinate, but we can also designate the location of a point by using a rectangular coordinate. And in this case, this one's very easy to see. So if I wrote this as a rectangular coordinate, can't do two things at once, I guess, we would say it's 8.66 to the right, positive, right, because it's to the right, and it's up 5 steps or units. Okay, so there's our rectangular coordinate. We can also write this then as a polar coordinate. There's two ways to write this as a polar coordinate. And the first way, we've been writing for some time. We always take the measure of the hypotenuse. Well, we have that right here. The measure of the hypotenuse is 10. Okay, that's also known as the magnitude. Okay, so we take that and we write that first, and then we write this little symbol here. That's the indicator that this is a polar coordinate, and we put the angle's measurement in there. And that's when we're using a positive direction, right? Let me use a red line to show you how we got there. That would be going from the x-axis in this direction, 30 degrees, okay? When it's negative, it's going to be going around, as you see the black line is doing. So if we wrote this as a negative polar coordinate, we would still say the line of magnitude is 10, but the measure of the direction heading negative would be 330 degrees, but it's a negative 330 degrees. Okay, so there's 3 different ways that we can write the location of that point, using our rectangular coordinates or using 2 different ways of writing the polar coordinates, one of them being positive and one of them being negative. All right, now to make matters even more confusing, we can also use negative magnitudes to locate this point. How do we do that? So I'm going to do one that's actually going to be in your notes so you can follow along with me in this. Hang on one second. Do I not have? Yes. Okay. And actually what we're going to do here in this example 2, which is on your packet, negative vectors, we're going to add together two different vectors, okay? So one of them is at -4 and -20 degrees, and the other one is at 5 and 135 degrees. So we're gonna have to draw out two different vectors, and I'm gonna show you how we're gonna actually draw this, draw each one of these. So let me go up to my notes right here. And we'll deal with the first one over here. And we're gonna write down the steps on how to do this. So the first thing we do, and I'm gonna write in blue so they stand out a little bit better. The first thing we're gonna do is we're gonna draw the vectors. All right, so we have our first one here, -4 at a -20. All right, so let's see what where's that gonna land us? So -4 would mean it's gonna be down in this fourth quadrant. I'm sorry, -20 means it's gonna be down in this fourth quadrant. So what we're gonna do first is we're gonna draw this -20-degree angle. So we start at the x-axis and we're gonna move clockwise now because it's a negative angle. Remember, if it's positive, we always start and go this way. But if it's a negative, which in this case it's -20, we're gonna go in a clockwise direction. So you're gonna start here on the x-axis and you're gonna go 20 degrees, about right there. Draw your line of magnitude. Our point is supposed to be out here somewhere, and we make this right triangle right here. Remember, this is 20 degrees, so let's fill that in. Actually, that's negative because it's down in the fourth quadrant. From there, we're going to actually now draw a vector on the opposite side of here. Watch this. I'm going to use green to do this. I'm going to extend this line. I don't really like the way that turned out. I'm just going to fix one thing. I want to fix this line. I'm going to make this a little longer because I don't feel like I made it where it's going to work out so good. So hold on one second here. Let me get this redrawn. So -20 might be about here. Then I'm going to draw this. Okay, so I'm going to extend this line of magnitude into the second quadrant up here. It's like a mirror image of itself. Okay, and I'm going to draw this here. So all I'm doing is just moving it into another quadrant here. We know that according to the information given, this polar coordinate told us that the length of the magnitude, the line of magnitude is 4. We know that as our hypotenuse, right? So I'm going to do the other side all in green so you can see it. So it stays the same. It's a mirror image. I probably didn't draw it exactly, so I'm going to make that a little bit better for you. At least try to keep it the same distance. That's not good either. Try again. That might be a little better. Might look a little bit more like it. Okay, and since I've drawn that line over at the same slant, I'm going to have a positive 20-degree angle up here now. All right, and this is going to be, we'll name this side as right, and we'll name this as up, right? So R and U. In your book, they're actually looking at these, they called these A and B. I'm just going to call them, we'll just call them up and R, right? Because that's what we're used to doing. All right, so we have everything that we need now to figure out how to write this thing as a rectangular coordinate, because we need to add these two polar coordinates together, but we need to get those in rectangular form to do that. Okay, so the second thing we do, and I'm going to do one at a time, so the second thing that we would do over here, second step, is to find the sine and cosine of the angles. All right, so let's do that. So we're going to find the sine and cosine of these angles. I'll stay in green here. So we know the angle is 20, so sine 20. And we'll go ahead and do the up first, and then we're going to do cosine of 20. I probably need a little more room, so let's just figure one out at a time. So the sine of 20 equals u over the hypotenuse, right? It's opposite over hypotenuse. So opposite that is the u side. We'll multiply both sides by 4, and if you put this in your calculator, you should come up with 1.37 over here. Okay, so this measurement is 1.37. And actually, since it's going in an upward direction, we're going to keep that called positive. Now let's find the cosine of 20. And that's going to equal adjacent or right over hypotenuse, which is 4. So when you put this in your calculator, you should end up with 3.76. Okay, so this one, and I'm going to, up here in the middle, I'm going to write out the first one. So we would have, and that's also in that one's going to be in a negative direction, right? Yeah, so that's negative because it's off in a negative. We're looking at the green triangle up there, right, is going to be negative. All right. The third thing that we're going to do is write the rectangular coordinate. So let's do that for this particular one I did in green. So we're going to have, right always comes first. So we're going to have negative 3.76r plus 1.37u. All right, there's the first one. We're going to do the second one using the same exact steps. We're going to leave step 4 here. We'll fill it in once we get the second vector over here done. All right, so the second one here, and by the way, we're going to write here what this one was, and I'll just leave it in green. Remember, this was negative 4, negative 20. We wrote that in blue down here first, and then mirror imaged it up in the other quadrant. All right, we're going to do the same thing over here for the next one. And I'll use purple over here. So now we're going to do this polar coordinate on our graph, 5 and 135 degrees. Okay, it's positive. That's great. So now we're going to start, and we're going to go in a counterclockwise direction to 135. So let's see, we're going to go from here to 90 to, let's see, that's going to be 180, so it's not going to be quite there. It's going to be 45 degrees past that. Okay, we're going to draw our line here and bring it down to make a right triangle. Okay, we know that the hypotenuse, or the line of magnitude, is 5, and we're going to figure out these two measurements here. Okay, this is what we have been doing, which is nice. Okay, now we have to figure out what this angle's measurement is. Okay, so we know we went 135 degrees to find the line of magnitude, right? That was our direction. We got over there. Now let's see if we can figure out what the actual measurement is at that point in time to the x-axis down here. So 180 would be all the way there. So we subtract 135 from that, and we're going to get 45 degrees. So this angle in here is 45 degrees, okay, which gives us our angles measurement to find the sine of 45 degrees, which is opposite, which is the up over the hypotenuse, which is 5. And the sine, I gotta rewrite that, equals 3.54. If you put that in your calculator, you should get 3.54. Now let's find the cosine of 45 degrees. It's going to be adjacent, which is right over the hypotenuse, right? So we're going to solve for that. And you're going to end up with 3.54 again. Okay? So now we have those measurements. Now let's go put these over here in a positive or negative. What are they going to be? Let's put those over here underneath our green rectangular coordinate. So you're going to have right comes first, and that's negative, right? Negative 3.54, right? Because look at the direction it's going. It's going this way, negative. And then plus, it's going up in a positive direction, so plus 3.54 up. All right, so here's the fourth thing we're going to do. Right in your step, you're going to add them. And when we finish with that, you're going to end up with negative 7.30 right plus 4.91 up. And actually, this is your answer right here. And you can box that in. Okay, so really, none of this was different than what you've been doing. You have been adding together two different vectors, but today we're looking at a negative vector and transferring it over, converting it over into another quadrant to make it all positive. Okay, so you can add those together by just transferring it over into the other quadrant. Okay, so let's do letter B. The only practice problem I want you to do is letter B, and we're going to do that one together right now. Excuse me, so you're sure you know how to do it. We're going to add together two vectors. So I'm going to make my little axis over here for the first one and my axes over here for my second one. All right, so the first one we're going to have is, let me find it in my book here, -2 and -15 degrees. So here's going to be one we're going to do a mirror image on. And this one over here is going to be 5 and 110 degrees. All right, so we have negative magnitudes. So we're going to want to move this thing over. All right, so let's put down here how we're going to find this. So remember, if it's negative, even our angle measurement's negative, we're going to start at the x-axis and we're going to move in a clockwise direction about 15 degrees. It's a smaller little angle down there. And we're going to draw that out. And that is 15 degrees here, negative, because we went into a negative direction. What I want to do, though, is I want to move this across from it. I'm going to take another color here, and we're going to move it over to this other second quadrant here. Just continue this extension of this line. So it's almost like it's looking at itself over here. And we have this drawn here. So now we are at a positive 15 degrees. And we can figure this out from here. So let's figure out our sine and cosine. Sine and cosine. Sine of 15 degrees and cosine of 15 degrees. So if you want to pause the video and see what you come up with, see if we both get the same answer here, that would be perfect. And then come back and check it out with me. All right, sine is always going to be opposite. Oh, I need to put in I didn't put in my magnitude here, and I need to do that. So down here it was -2. Up here it's really not negative down there. It's still positive, but let's go ahead and put it up here. 2. All right, so we have up and right. So sine is opposite, so we're looking for the up measurement here over the hypotenuse, which is 2. So the up measurement here is going to be 0.52. Cosine 15 is going to be right over hypotenuse. Right is equal to 1.93. And we'll write this out. It's going to be negative 1.93 right plus 0.52 up. Okay, that's that measurement. We're using the same steps as we did before. So let's draw the vector on the second one over here. We have 5 and 110. Do this one in, let's see, how about pink? All right, I'm going to go 110 is going to be, let me look at something here. Yeah, okay, 110 is going to go, there's 90, 110. It's not going to be very far past the y-axis here. You know, none of these are ever perfect. It's just a drawing to help us work through our measurements when we draw them, but we make our little thing here. We have an up and a right side. What is our angles measurement now? We know that to get to this point was 110. So in order to make it all the way to the y-axis down here, right, would be another 70, right? So that angle inside that triangle is 70 degrees. So let's find our sine and our cosine. Sine of 70 is always opposite, which is our up measurement over the hypotenuse, which is 5. And then for cosine of 70, we're going to solve for the right side over 5. Up is equal to, and you should get 4.70. And for this measurement, you're going to have 5. And right is going to equal 1.71. And we're going to put that together in its rectangular coordinate form. So you're going to have negative 1.71 right plus 4.70 up. All right, so now we have these two that we need to add together. So right below that, I'll put it back in blue. And I'm going to write, if I add these together, you should put them on top of each other, but what you're going to end up with for your answer is negative 3.64 right plus 5.22 up. Okay, so really when you do these over time, they become a little bit more fun as you understand what's happening here. You're taking a polar coordinate, you're graphing it on your graph, you're using your trigonometry functions to figure out your sine and cosine to find your side measurements, and then you can write those in a rectangular coordinate form. I can add those two vectors together to make one big vector, and if I were to put those together and graph those on yet a third one, that would give me a new location for a point, and it would look different than what either one of those those graphs, those images on the graphs are. But that's how we do that, and that's how we work with a negative vector. Just transfer it over into a positive form, into a mirror image of itself, into the opposite quadrant. Okay, so I hope that was helpful, and I will see you shortly. Thank you so much for watching.